good evening and welcome to Science Cafe Concord. My name is Dan Marchek and I'm one of the co-founders of Science Cafe, and I'm glad to see such a big crowd here tonight. This is going to be great. Science Cafe New Hampshire has been around for almost 5 years. We've hosted over 40 sessions, and we recently opened a new one in Concord, which is apparently very popular, so I'm real glad to see that. So if you think about it, over the course of the last decade or two, some things have come along that have changed, I guess, marriage. And the first one would be GPS. So we can no longer argue about directions. And now, after the panel tonight, we shouldn't be able to argue about quality of driving either. So the format for those of you who have not been to a Science Cafe is very easy. It's a question and answer session. We will give the panelists a couple minutes to introduce themselves, and then David and I, will walk around and have a microphone and let the conversation follow the questions that you have. So without further ado, I'll introduce our moderator, David Brooks.
Thank you. Couple quick comments. First of all, if you want to have a question, raise your hand. It's just like school, and we'll come around with a mic. Please wait for the microphone because ConcordTV is filming this, and they've put up. This is the fourth one they filmed, and they put them on their website, and they distribute it on some TV distribution thing. And there are a dozen or two channels around the country that are streaming this as well. Not streaming it, but they have syndicated it. So you will be on TVs in like Washington State and Virginia and places like that. So if you're hiding from the authorities, this is the wrong place to be. The topic tonight, as you know, is autonomous cars. And the hard part of doing the Science Cafe is getting panelists who are knowledgeable, will work for free, or at least for a beer, and are available. But luckily we got 3 of them, which is difficult because there aren't any self-driving cars in New Hampshire, and it's not like there's a self-driving car industry or even a self-driving car, research centers here yet. So that made it a little difficult, but we were able to get, we've got software, we got electronics, and we've got mechanical from Dartmouth, UNH, and NHTI, so we're pretty well represented. I'm extremely pleased with this panel. And what I'm going to do is I'm going to let them use the microphone and introduce themselves very quickly, give them about 3 minutes each. So with that in mind, grab a microphone and introduce yourself. Tell us why we should pay any attention to what you have to say, and then we'll go from there.
Well, if I knew how to do that, my students would pay more attention,
That's
right?
true.
Yeah. All right, so my name is Andrew Kuhn. I'm an associate professor at the University of New Hampshire. I'm in electrical and computer engineering. And my primary interest is in human-computer interaction. And so within the realm of driving, in fact, is where my interest resides. And of course, that includes then automated driving, autonomous driving. So some of you might have heard of Project 54, perhaps, some time ago. If you're involved with any of first responder agencies, I don't know if anybody has first responder agency something or other, but if you get pulled over by a cop, you can start talking about this perhaps. But if you ever look into a police cruiser, for example, you'll see that they're very busy places, lots of equipment that does not necessarily talk to each other. So this maybe decade-long project called Project 54 at the University of New Hampshire integrated devices in police cruisers. So there were about 1,000 units, mostly police cars in New Hampshire, that were on the road for a good period of time. So that's where our efforts in driving started, and now we have a nice driving simulator lab where we conduct some research with unsuspecting students and try to see where exactly they might look using some eye tracking, what kind of speech interactions might work in driving, and so forth. There's also a really nice conference series that we're very heavily involved in called Automotive User Interfaces. So we actually hosted that in 2012 in Portsmouth, and we continue to be involved in that. So I'm very excited to be here today. Thank you, David, for reaching out, and thanks to Science Cafe for having us here. And with that.
Okay. Well, good evening. I'm Sean Smith. I'm a professor of computer science at Dartmouth and director of the Institute for Security, Technology, and Society. And I guess I got started not in academia, but out in the real world doing a lot of security analysis and advising for citizen-facing agencies in the U.S. government that were wondering what this new web thing was and how it would impact their lives and what the issues were. Then spent some time in industry and then finally decided to move north and try this teaching thing. My interests are, I guess, cyber-physical systems and security and privacy issues and other kinds of issues that happen when we take things that weren't computers and shove computers into them. And what are the, and that, so part of that includes self-driving cars, autonomous cars, electronics inside cars. Let's see, last summer I taught a course on risks of the Internet of Things to society, where we covered a lot of stuff, and it was interesting. After we talked about some of the risks of hacking cars, and the Wired article came out where it was demonstrated, and it's like, oh, wait a minute, the students are kind of impressed by that. Hey, we just read in the New York Times what you talked about. Now I guess how to get people to pay attention is going to be on the final.
Hi, I'm Joe Cunningham. I'm the program coordinator and professor of Robotics and Automation Engineering Technology right down the street here at NHTI. We have a program which we like to call advanced manufacturing, where we're taking the routine and boring kind of stuff in manufacturing and having robots and automation do it. So it kind of somewhat applies to automation, automated cars. Before that, I worked many years as a manufacturing engineer, an industrial engineer. One of my other specialties is efficiency through waste reduction through lean manufacturing. I also teach a course on that and do some work on the side doing that. So.
You know, how realistic is this? And are we talking about something that is, you know, I mean, I know Google's doing it a little bit, but is this something that's actually going to be on the roads within, say, 5-10 years, or is this going to still be science fiction 10 years from now? What do you think?
Well, from what I've read about, I think it depends what we're talking about. If we're talking about fully automated cars where you just, you know, get on your phone, you push some buttons and it shows up and you go in and it drives you there, I think it's going to be quite a bit away, a number of years away. If we're talking about, you know, features on cars that are more adaptive cruise control, accident avoidance, some of that's already available. So I think it's going to be a progressive trend towards that.
I guess, well, reading the crystal ball is always hard because there's all these, not just the technology, but there's issues in terms of all the governments involved, the states, the different countries, where are we going to see these things emerge? But I would say let's look back 20 years. People still bought vinyl records 20 years ago, and they listened to things on the radio that was actually broadcast electromagnetic. You know, they didn't stream over the internet. There wasn't internet in the home at that. You know, there's sort of. I mean, look at the changes we've already seen in society over the last 20 years, and you know, if we just extrapolate along that, is it that far out to imagine we might have these autonomous cars? I don't know. A friend of mine at SRI out in Mountain View, California, who's a cyclist, I mean, not only do they regularly see Google cars, but he has a problem because he never trusts them at stop signs. Because a driver, you can look at the driver when you're on a bike, but the car, you just don't know what it's thinking.
So I think many of you are probably familiar with Ray Kurzweil, right? And the way he sees, and I have to say I don't necessarily agree with everything that Ray Kurzweil says, but one interesting thing I thought that he points out is that if you look at a lot of these technologies that have developed over time, when they started out, it looked like, oh, websites are going to take forever to take on because, you know, look, we have one new website every hour or something, and this is going to take forever. And then a lot of times, if a technology is successful, then it turns out to be an exponential growth as opposed to a linear growth. And people are sort of stuck with looking at the linear trend for a while and extrapolating the linear trend, which might take many years, but don't realize that there's that curve coming where it shoots up. So, you know, it is a crystal ball, and we're not going to have an actual, I think, answer here today that we can bet our lives on. But my guess would be that it is probably sooner rather than later that we're going to see at least very significant very significant changes in driving towards autonomy.
Alrighty, and with that, we will go to the crowd, and I will start in the back.
The current path ahead seems to be we're going to place all of the intelligence technology in the vehicles themselves. I'm just wondering if you see that as a viable strategy forward, or if you think at some point to do autonomous travel on a large scale, we're going to need to put some of that intelligence and control in the road, highway infrastructure.
So actually, we have a couple of projects that are related to this idea of vehicle to vehicle and vehicle to infrastructure. And just recently, the NHTSA administrator was in Boston for an interesting session. He was talking about this question, and the answer is we don't know. So basically, one option is that, so you have this technology, right, the vehicle to vehicle technology, and the idea is your car is going along and sending out signals, and other cars around it are picking it up, and that makes it much more safe to drive, right? So for example, the car around the corner can find out that you're coming around the corner and therefore not collide with you. And so there are these interesting ideas with that. There's also the same with infrastructure. But of course, today's autonomous vehicles, for example, that Mercedes you mentioned, doesn't have that. And they simply use various sensors. So do we actually need the vehicle to vehicle or vehicle to X? We actually don't know. So by we, I mean the administrator of the National Highway Transportation Safety Agency doesn't know. So I think by and large the agreement is that we don't know and we're going to have to explore that.
I guess a couple of, one problem, if the intelligence doesn't live in the entity itself, but instead is somewhere else, or we're going to get to the cloud, or we're going to go, well, what if the cloud's not available? What if there's a lag? What if there's we had a visitor coming up from Boston driving some kind of funky rental car that needed to place a cell phone call to figure out whether he was okay to drive it. He stopped for a picnic with his family and was not able to start the car because he was in one of New Hampshire's many dead zones. And the only way to fix the problem was to have the car towed to cell coverage again. I mean, so there are issues like that. I've been doing a lot of work in the power grid, which has a lot of cyber control. And half the industry says, oh, we love this internet thing and putting our stuff in the cloud. And the other half is, we're terrified because we don't know what we depend on now. And we don't know what kind of failure somewhere is going to cause our stuff to go down. Now, as far as vehicle to vehicle, I mean, some of the really far out visions, there's a book, Future Ride, which if I guess anyone buys a copy, then I'm going to go poke Peter Wayner, the author, who's an old friend of mine, and say he owes me a beer. But there's a book, some of the far out visions of autonomous vehicles are, well, if they're all talking to each other, then they can drive a lot closer and they can save mileage, there's all these visions of this. And then put on my security hat and I say, well, have you really tested the interface there? I mean, you put a server on the internet and, I speak the wrong thing to it and it falls over. What's going to happen when I do that to cars? I know people in the government, tire pressure monitor, TPMS. It's very hard to have a wire coming from inside your tire to your car because, it spins around and all that. So it's this little wireless thing and it gets, you irradiate it and it comes back with a number and then that's how it talks to your car. I know people in the government are very concerned. This is a great way to build an IED that will explode when that diplomat's car drives by, because you can identify that diplomat's car. And the obvious solution is, well, don't have it talk. Well, okay, then you blow up when the car goes by that's not talking. So there's a lot of, as you start to communicate, the hackers that took over the Jeep did it with I guess it was a cell phone thing. And then later on, the UK, it was demonstrated doing it over a digital radio. The more channels you have coming in, the more chance for the attack surface gets bigger. So it gets interesting.
What was the final resolution on that so-called runaway Toyota Prius in California? Has anybody seen anything on that? Obviously, I don't think that thing was hacked. But was there any indication on whether that was the driver pulling off a stunt, or was there actually something wrong with the code in the car, or was it a mechanical failure?
I don't know if it was the Prius. Toyota ended up settling.
I don't believe the Prius was at fault. That's my recollection. There's also some interest.
But there was I'm seeing in my head the news article with the damaged car. There was, I don't think this was a Prius, but it was another kind of Toyota that was a either the manufacturer either lost the case or settled it, admitted guilt and settled it. So that does, yeah, and there are sometimes there are casualties. The Airbus A320. This is back about 30 years ago. Oh, a fly-by-wire airplane. It's going to be, a lot of the pilot stuff is going to be automated. And there were lots of disaster predicted, and it didn't quite come to pass. But then the Therac 25 was this computer-controlled radiation device, and it did kill people. So it depends. We sometimes get it right. We sometimes get it wrong.
And I'm glad you brought up casualties. So the very first Automotive UI conference was held in Germany in Essen. And Essen happens to be one of the places where there were a lot of coal mines. So coal was big, obviously, to generate energy. So we actually had a chance to visit one of these coal mines. And I don't know if you've had a chance to visit one or a mine in general, but they're really tough places. I mean, it's incredibly difficult work. It's incredibly dangerous. And the point is, back in the 1800s, basically at least once a day, someone got very seriously hurt, often died. And that was just part of life, absolutely normal, that as you need coal, there's no argument here, and people go down into the bowels of the earth, they dig it out, and it's tough work, and some of them actually will die, and that's how life is. But fast forward to today, there are about 30,000 people who die on the roads in the United States of America, every year. How is that? How is it possible that this long into the future, right, we basically say, yep, practically 10 people a day will die on the roads, and that's how life is. And there's just nothing there's stuff we can do about it, but basically this is normal, and this is okay, and this is how it is. So I think that as we talk about casualties and as we think about what exactly autonomous driving entails and what kind of risks it entails, we also really have to think about what reality is for us right now. And it's actually it's not really that great, right? I mean, this is way too many people who are getting killed, literally getting killed on the road today.
Do you envision that even in the car-to-car communication network situation, that there still will be overrides eventually in the design of all these cars, so that a passenger who has at the controls, if you will, would be able to make a decision that something is going wrong with the software, be able to take control manually of the car, and even if it's in communication with other cars, the other cars will just take the input of what that driver is actually deciding and use that to respond, and that might be one way to avoid some of these uncontrollable failures?
Well, right now, what I've seen with the Google car, that cute little bubble car, there is no driver controls in that I've seen. They do have some of the other models. They use the Prius, they use a Lexus, and they do have drivers there. But I think the plan is way in the future, when they get to the latest stage, that it's going to be completely autonomous with no controls.
On the flip side, there were some discussions in the UK of how to license self-driving cars, and at least it was proposed that, they should still have human override, and the human should be sitting there ready to take control. So the vision of, this will eliminate drunk driving kind of goes away. Even if you're going to riding in a self-driving car, you still have to be sober. There's also been some allegations with some of the fly-by-wire things where the pilot will want to override, but the computer says, you are moving that aileron, moving that thing too fast, and we're going to slow it down for you. And there's been no clear smoking gun, but there's a lot of allegations of the override doesn't work as well as it ought to.
So since I'm involved in human-computer interaction, I think my biggest concern is that people will not really do that takeover, will not take over. So, NHTSA designates cars as, let's say, level 2 or level 3 or level 0, 1, 2, 3, 4 automation. And level 2 is sort of like you can have both the steering wheel and the gas brake pedal controlled by your automation, but you're supposed to be in control. So you're carefully watching the road. Now imagine me, I'm not sure I'll be able to do that, right? So the car is driving itself. I'm probably going to be very tempted to do other useful things. And that's the problem. So there's nice research on, how long, one of the big questions is, how long does it take for the driver to take over. One of my students here in the audience is actually conducting some experiments with this right now. We're looking at, well, okay, we tell you now it's your turn. When will you actually do it? Does it depend on the task you were involved in? And for that matter, the task might have been napping, or it might have been watching a really interesting show, or it might have been writing or reading, and my guess would be that you're going to be resistant to taking over. So I think I would be concerned about that takeover time, and people, once they even take over, then what? There's good research on showing that once people do take over, they don't do as well for maybe a minute. So again, I think it's a very good question. How do you make that leap? And I think a lot of car companies are expecting that. For example, Volvo is talking now about deploying about 100 automated vehicles in Sweden, but they're going to be automated for specific parts of the road. So that means there will be that part where now you have to take over. How does that actually happen? I think that's a really difficult problem for human-computer interaction designers.
There's a project at Rutgers looking at the other angle of how would I have a remote driving car? So I'm sitting in my office or in my building, and I'm driving a car somewhere else. And there the case is, well, when there's a communication lag, the car has to take over during this critical 3-second period. And even that's a hard problem. They're not anywhere near rolling that out on real roads.
So my question is, the car will know how to drive itself, but will it know something as simple as locking itself, closing the door, turning itself off, or do you have to actually do it on a remote or tell it to do it? And then if this is the start of something, will the next level be something to maybe get the car off the ground and maybe hover for a little bit?
Please let it be noted it took 37 minutes for flying cars to be mentioned.
So do you have to tell the car to lock itself like the computer on Star Trek to do it, or do you have to, or do it itself?
I suppose if that's what you want to have it to do, that'd be an easy thing to do, I think. I mean, I have a Prius, and I just touch my handle and it locks. So it does all kinds of things I don't know what it's doing half the time. So I don't see that as a problem. As far as flying, I have no idea.
This sounds like the elevators from Hitchhiker's Guide to the Galaxy, right? They know. But on the other hand, there's good research on that where people are looking at, well, where are you going? So based on simply your GPS traces and past history, a colleague of mine in Microsoft Research is looking at, well, where are you actually headed? Are you headed to grandma's? Are you headed to, I don't know, a store that you usually go to and so forth? So I think with autonomous vehicles, it's going to be actually quite important, right? So once I'm done here, I'd like to get picked up and go. And so my autonomous car ideally would actually somehow, I don't know, in this obviously cool future, know that around 8 o'clock I'm done. But maybe that's because I get up and I start walking and somehow my car knows. How? I don't know. There's a security expert who can tell you how that happens with the network safely.
Well, I mean, I just put a new thermostat in my house. It's real fancy, and it anticipates everything we do after we tell it to schedule. So you never even know the heat's on. It's just the right temperature. So I would think if it can do that, I mean, a car can do any of that.
I guess I'm of two minds. So one is actually people are looking at not just the cars, but integrating the car with your house. So as you get close to home, now we'll turn your furnace up, and we'll automatically open your garage door. And so that's just sort of, you can imagine those bells and whistles. At the same time, how many bells and whistles do you have in your electronics that you never use because they're too complicated? I'm also thinking, I was at a conference last week. There was a revolving door in the hotel. It was very difficult to get through the revolving door because it had some intelligence about where you should be standing and how you should be moving. And so you wouldn't be standing in the right spot and it would stop. People are like, what? So yeah, it's just, it's a matter of technology. Now flying, I don't know.
That's how the robot overlords are going to do it. They're going to trap us in revolving doors, and then we're helpless.
Yeah, I'd like the conversation to put itself in reverse for a minute. Do you three think the world needs a self-driving car?
Well, I guess give a couple of answers to that. What if we could eliminate those 30,000 deaths a year? What if we could, if a fleet of autonomous cars were on the road instead of the ones we have now that could get vastly improved fuel efficiency because they're all cooperating and stuff? What if we didn't need as much oil? Would we care about the Middle East as much? Would we have soldiers in the Middle East if we didn't need the oil? So there's a lot of other social, how much space do we use for parking and parking lots? And that's, I mean, so there's sort of, there's a potential huge upside for some of these visions. Of course, the downside is, why do you need a fancier toy? Why not a simple one? And technology, we as a society have often pushed technology long before it's actually, you know, for its own sake as opposed to whether it's doing any good.
As an engineer in another life, I am fascinated by the technology part of it. But we talked about overrides, and that's great for emergencies. But what about those of us who enjoy driving? It's a thrill of driving, the art of driving. Should we have an override for the days we just want to, you know, get out on the turnpike and let go? Or do you envision that once we get past the initial self-driving cars, that eventually they'll all be self-driving?
Well, I mean, that's, yeah, I think there's something to that, because people just don't drive just plain old mundane cars. They like, you know, sports cars. They like pickup trucks. They like the image of cars and trucks. So I don't know. A lot of these cars you see out there, like the Google cars, I mean, they're cute, but I don't know if everybody would want to be in a car like that.
I think that's a key question for automakers. I think I would be scared if I was an automaker, and you know, it's the image that you're buying, right? So if I buy a neat car, I'm buying, you know, someone put hours and hours of work into figuring out what the sound of the door will be. You know, when the thump, that should be really something, right? And all those things will go away if you're simply just part of some group of people jumping into cars, pretty much like buses that are little pods running around. Are you even going to have a car? Will it be yours? Does it even make sense to have a car? Or should, you know, my town of Durham have 27 little pods that run around, and every now and then someone jumps into them? So I think that the answer, my personal feeling is the answer to your question is yes, people will basically have cars to ride around just for the fun of it. But that it's really inefficient and unsafe to do so. So for the larger society, I think it's better to have automated vehicles which are safe and let you do work, right? Or fun, or sleep, or whatever it is that you wish to do. So that's my personal preference anyway.
I think that is it.
All right, well, thank you all for coming, and please join me in thanking our panel. All right, thanks for coming. See you next month.